Good morning, day 2. Just hanging out alone here. I'm wearing my homebody shirt, trying to make myself feel better about being home during this quarantine. Today we're going to talk about colligative properties. This is a pretty easy topic, but there's some things that are related to electrolytes that you'll see. So I'm going to share my screen in a moment. Oh, sorry. Here we go. Okay, so we were here yesterday. So let's kind of move on with colligative properties. Okay, so colligative properties are properties of a solvent that change when a solute's added. So we're talking like water has normal properties, but then when I add stuff to the water, those properties are going to change. It depends on the Van't Hoff factor, which are the number of particles that are separated in solution, and the concentration. And the larger the product of these two, the greater change you'll have. Okay, so in this circle, we're drawing like a close-up of a thermometer. The freezing point is here. Remember, if we're talking about water, it's 0 degrees Celsius. The boiling point's up here, 100 degrees Celsius. When I dissolve a solute in water, the freezing point and the boiling point are going to change. So this is what I would have you do in class. Put your hands like this, where the top one represents the boiling point and the bottom one represents the freezing point of water. So when I add a solute, this is what happens. Whoop! Okay, try it again. So when I add a solute to a solvent, it goes like this. Whoop! Okay, so what happened to my boiling point? Started here, went here. So it went up. Freezing point went down. So to summarize, when a solute is dissolved in water, the freezing point goes down. It's called freezing point depression is the technical term. The boiling point goes up. It's called boiling point elevation. Okay, flip to the next page. Okay, so your paper is gonna look a little different than mine because I adjusted it this year. Okay, so what you guys are going to do to determine which is going to have the greatest effect on the boiling point or the freezing point is you need to figure out first, do you have an electrolyte or a non-electrolyte? Second, you need to figure out the Van't Hoff factor. So this is what I would do. I would look at C12H22O12 and I would ask myself, does it start with a metal? No. Does it start with H? No. Does it end in COOH? No. So it's not an acid. Does it end in OH? No. So it's not a salt, it's not an acid, it's not a base, so that means it's a non-electrolyte. Non-electrolyte. Same thing over here. So non-electrolytes, the Van't Hoff factor is always 1. That means it stays together as a whole thing going into water. So after you know that piece, you take the molarity, concentration, and you multiply times the Van't Hoff factor. So I did 1 times 1 equals 1. For the next question, it has a molarity of 2. 2 times the Van't Hoff factor 1, because it's a non-electrolyte, equals 2. The one that has the biggest number is going to have the greatest change. So the boiling point will either be the highest or the freezing point will be the lowest. They are the same. Okay, so that's why I circled this one. Okay, example 2. 1 times 1. So where did I get that 1 from? So I know that C6H12O6 is a non-electrolyte. It's not a salt, it's not an acid, it's not a base. So its Van't Hoff factor is 1. 1 times 1 is 1. On the next one, I have an electrolyte. How do I know? It begins with a metal, so it is a salt. And now I feel like on that little mini quiz that you guys were doing, it wasn't a quiz, doing yesterday, the Van Hoff factor was a little tricky. So it might be helpful to think of the names. This is magnesium hydroxide. So you're going to have magnesium hydroxide, but when I look at the formula, I have 2 hydroxides. So it's MgOH. So that gives me a Van Hoff factor of 3. So I'm going to multiply 1 times 3 equals 3. And since that number is bigger, that one has the greater effect. So therefore, the larger product means you have the higher boiling point. And the lower product and the higher product also means you have the lower freezing point. It doesn't change. Whichever number is bigger is going to have the biggest effect. So the greatest boiling point change and the greatest freezing point change. Okay, so in the next one, which solution will have the highest boiling point? You're going to do exactly the same. So push pause right now. Push pause and answer those questions. I do want to give a shout out to the people who were trying to do the homework at the same time that I was putting the video up, and found all my mistakes yesterday, like Kenzie. Thank you, and like Erica for doing it over again, and Emily and Amanda, and who else? Sean, thanks. Okay, so push pause, and when you return, I'm going to go over the answers. Okay, so you should have done this on your own. Okay, so molarity times the Van Hoff, 2 times 2. So I got 2 from this because it's an electrolyte. 1 times 3, MgOH. So when I multiply, I get a 4 here and a 3 here. 4 is greater than 3, so that is your answer for number 4. Electrolyte, because it begins with a metal, I have 2 Als, 3 SO4, so my Van Hoff factor is 5. 1 times 5 is 5 over here. I have an OH at the end, but it's with carbon, so that makes it a non-electrolyte, so my Van Hoff factor is 1. So 5 times 1 is 5. So since they're both 5, the change is exactly the same. So you could just circle both or say they're equal. Number 5, 1 times 2 is 2. 1 times 3, K, and SO4 is 3. So this one wins. In the bottom one, we have 2 non-electrolytes, so it's 1 times 1. 2 times 1, because the Van Hoff factor of non-electrolyte is always 1. So this is your answer. Okay. Oop. Push pause and do the rest of those. Push pause now. Great. When you come back, here are the answers. So same idea. 1 times 1, 1 times 2. So this one's bigger. 2 times 2, 1 times 3. Mg, NO3, NO3. So that one wins. 2 times CaCl2, this is a Van Hoff factor of 3, Ca, Cl, Cl. So that's 6. And then NaNO3, 2 times 2 is 4, so the 6 wins. And then this one is just like number 4, exactly the same, 5 and 5. All right, so if you want to, we can just talk about this. Okay, normal boiling point of water is 100 degrees. So what will happen to the boiling point when I add salt? The boiling point will go up. So how does that affect cooking time? So since I'm boiling at a higher temperature, let's say I add my pasta as soon as it starts boiling. So normally it boils at 100, I add my pasta, let's say it takes 10 minutes. If I'm boiling at 105 degrees now, I add my pasta, the cooking time is going to go down. So like a lot of people add salt for flavor, but it also decreases your cooking time. Okay, so this is the other real life application. This is why we add salt to roads in the winter. Okay, so freezing point of water is 0 degrees. What happens when I add salt to the freezing point? It goes down. So how does that affect our driving on icy roads? So when I'm adding salt to the roads in the winter, it is going to stop the water from freezing at 0 degrees. The water will now freeze at a point less than 0 degrees. So then I can, Celsius, remember, so this is 32 degrees Fahrenheit. So let's say it's 25 degrees Fahrenheit. Instead of it being all icy roads now, they're still watery. So it's not as dangerous. So explain how putting salt on icy roads makes it safer to drive at lower temperatures. They will stay liquid at lower temperatures instead of ice. Okay, so that's it with the notes, and this is really it with the whole unit. So what I want you guys to do now is push pause and do the mixed regions questions. You are going to need your reference table to use your solubility curves. So this should probably take like 20 minutes or 15 minutes. I don't know. It's going to take some time. So you can like FaceTime with a friend or something like that, but you should be practicing these, not just copying the answers. So push pause, and when you unpause it, I'm going to go over the answers. Got it? Okay, so number 1, a gas is most soluble. So gases, think fizzy soda, low temperature, cap on, high pressure. Number 2, which curve represents gas and water? It's the only one that goes down. B. 3. Okay, this one's tricky because normally we talk about which will have the lowest freezing point, and that's the one with the most particles. But this one asks for the highest freezing point, so it's the opposite of those colligative properties we were just doing. So that's why it's choice A. All right, 4, what occurs when salt dissolves in water? Ions increase because salt splits up and the freezing point decreases. Choice C. Number 5 is a graph question. So go to 55 grams on your graph on the left. Go all the way over till it hits the NH4Cl line. Read down approximately 57 degrees. Number 6. Based on the solubility chart, which of the trials seems to be in error? So this is for KNO3, so I just went to all these temperatures to see which numbers were correct, and I found that number 4 was incorrect. Okay, as temperature increases from 0 to 25 of NH3, how much can be dissolved in 100 grams of water? So at 0 degrees, figure out what you have. At 25 degrees, how much do you have? Did it go up? Did it go down? It went down because it's a gas, and decreased by 40. Number 8, which of the salts is most soluble? At 60 degrees, go to 60 degrees, read all the way to the top, NaNO3. Number 9, a saturated solution is at equilibrium. That's one of our definitions. Number 10, a solution contains 90 grams of salt dissolved in 100 grams of water, so at 40 degrees. So plot these 2 points. Unsaturated solution means it has to be under the curve. So the only point that is under the curve is NaNO3. On the next page, we have 70 grams at 10 degrees. So if you plot that point, it says how many additional grams are required to saturate the solution. So see where it hits the line at 80 grams. So we need to add 10 more. Okay, 12. So this is asking for how much potassium chloride, KCl, can you saturate in 300 grams? So you have to do it per 100 grams first. So go to 10 degrees, go to where it hits KCl, boop, that's at 30 grams, 30 grams per 100. So if we have 300 grams of water, you would triple it, 90. Alrighty, 13, the most concentrated, has the most stuff in the least water. Remember, concentrated means it's strong. So the most stuff in the least water is choice 4. Number 4, most concentrated means highest on the curve, like holds the most. So that's choice A. 15, a saturated solution would be most dilute at 0 degrees, like holding the least stuff at 0 degrees. Okay, 16, what is the molarity of a solution that contains 30 grams of NaOH in 500 milliliters of solution? This is a 2-step question, so listen carefully. 30 grams times 1 mole divided by 40 grams. So that's 3/4 or 0.75 moles. Then the molarity is equal to moles divided by liters. You have 500 milliliters. So first you have to switch that to liters. 500 divided by 1,000 equals 0.5. So molarity is 0.75 divided by 0.5, giving you choice C. Number 17 is the definition of molarity, moles of solute per liter of solution. Number 18 is total gram. This is a 2-step molarity problem as well. So we have 1 molar, F equals X moles divided, 1 molar equals X moles over 0.5 liters. So 1 times 0.5 is 0.5 moles. Then you're gonna multiply times the mass of HI. H is 1, I can't remember I think it's like 127. Yeah, that makes sense. So you have 0.5 moles times 128 grams over 1 mole gives you 64 moles. 19, what is the total number of moles of solute in 2 liters? This is a 1-step. So 3 molar equals X over 2, cross multiply, you get 6. This one is kind of a pain. Okay, so which preparation produces a 2 molar solution? And they give you all the masses. So basically, I'm just gonna go through the answer. So basically, you have to figure out the moles for, I'll just explain. You'll have to figure out the moles for each of these. So 90 grams divided by 180 is 0.5 grams for A and B. So then you divide it by the liters. So in choice A, it's 0.5 divided by 0.5, that gives you 1. In B, you're doing 0.5 divided by 1 is 0.5. And the next two, 180 grams divided by 180 grams is 1 mole. So D is 1 mole divided by 1 liter is 1. So C is 1 mole divided by 0.5 is 2. All right, and then 2 more. Which concentration of a solution of CH3OH in water has the lowest freezing point is like what we just did when you multiply the concentration times the molarity or times the Van Hoff factor. So since the Van Hoff factor is the same for all of these, CH3OH is 1 because it's a non-electrolyte. 0.1 times 1 will give you the highest number, A. So the greater the concentration, the lower the freezing point. And then number 22, boiling point increases, freezing point decreases. And that is it for today. So good job. I'm going to put in another electrolyte practice, and I will take the higher of the 2 grades, okay? So some of you emailed me and were worried about your grade from that thing yesterday. Do it again today, and I will take the higher of the 2, okay? All right, so tomorrow we'll talk probably about working on that review sheet, okay? Hope you are doing okay in the quarantine. Talk soon, bye.